All right, we're going to go over the atom study guide. So first we are asked to, how do we determine the following? All right, number of protons. Well, number of protons is equal to the atomic number. Okay, and the atomic number is the whole number or the bottom number on the symbol on the periodic table. So if you were looking, it's the top number. I said the bottom number. It's the whole number, top number. So that's the atomic number right there. Okay, so that's the number of protons. Number of neutrons, you're going to do the mass number minus the proton number or atomic number. Okay, that'll give you your number of neutrons. Now the mass number is basically the protons plus the neutrons. So the number of protons plus the number of neutrons gives you your mass number. Number of electrons, it's the same as protons in a neutral element. All right, the charge is the balance between protons and neutrons. I said neutrons, electrons. Sorry, y'all, watching the weather right now. All right. So if you have more protons, you would have a positive charge by however many more protons than electrons you have. And then if you have more electrons than protons, you'll have a negative charge by however many more electrons you have. The nuclear symbol is going to be the symbol of the element, the mass number in the top left, proton number in the bottom right, and the charge, whatever it may be, in the top right. All right, isotope symbol is just the name of the element dash its mass number. And average atomic mass, the given one that you could find, is on the periodic table, and it's the number on the bottom that's not a whole number. It's the decimal number. So that's your average atomic mass. Okay? All right, so now let's use this information to try to find this chart right here. Okay, so to successfully complete this, you need a periodic table in front of you. Okay? All right, so at this point, we know that we have chromium 50. Chromium is element atomic number 24. That tells us that we have 24 protons. We know the mass is 50, so that means that 50 minus 24 will give us our number of neutrons. So our number of neutrons is 26. Number of electrons is the balance between protons and the charge here. So we have 2 more positives than negatives. So that means we have to have 22 negatives. The average atomic mass is the bottom number on the periodic table. And for this one, it's 52.00. And then we're going to do our symbol. So we got the symbol. We've got the mass, atomic number, and charge. Okay, all right, now let's look at the next one, and we know that it's atomic number 16, which is sulfur, and we know that the mass is 34. That tells us that our number of protons is 16. If we have a mass of 34, then our number of neutrons is 18, because 34 minus 16 is 18. We have 2 more negatives than positives, so we have 18 electrons. Bottom number on the periodic table is 32.06. Then we have the symbol, sulfur, mass, atomic number, and charge. Okay, now we know that we have 5 protons on this one, so that means that's our atomic number. That is element boron. All right, and the mass is going to be protons and neutrons, so that's 11. So that gives us boron 11. And we have no difference in protons and electrons, so that's charge of 0, so that gives us the same number there, 5. That's the bottom number on the periodic table, the average atomic mass, and then your symbol, be like that. All right, this is the symbol, so this tells us that the mass is 107, atomic number is 46, it's element palladium, and the mass is 107. Protons is the atomic number, so 46. We have 2 more positives than negatives, so we have 44 electrons. And neutrons is 107 minus the number of protons, 46. So 61 is going to be our neutron number. And then our average atomic mass is the bottom number on the periodic table. All right, now here we know we have a charge of 0. So that means protons and electrons would be the same number. That tells us that we're dealing with the element 21, which is scandium. All right. The mass is protons and neutrons, so that's going to be 44. Let's give us a little dash 44 there. All right, and then our symbol, mass, protons, charge, and the average was 44.96. Okay, and last we have a mass of 132, 54 protons, 0 is the charge, just kind of got cut off there. So that means our electrons is the same. 132 minus the protons is 78, that's the number of neutrons. And this is element 54, which is xenon. And the symbol, the mass, atomic number, and charge, and then the average mass from the table is 131.29. Okay, all right, little couple random questions. So what subatomic particle is responsible for the identity of the atom? That would be the proton. Subatomic particle that occupies the nucleus, that would be the proton. And the neutron. All right. Charge do protons, neutrons, and electrons have? Positive, neutral, and negative. Subatomic particle used for bonding, that would be electrons because they are located on the outside, easiest to get to. Purpose of neutrons, they kind of act as a buffer between the positive protons in the nucleus to help keep the nucleus from splitting. Okay, kind of reduces that repulsion. Isotope is same element. Okay, so that we're talking about number of protons is the same. Yes, baby, I see that you broke your dart. Okay, I see you broke your dart. All right, he wanted me to notice he broke his dart. Same element, so same number of protons, but they have different mass. Okay, so it's basically 2 atoms. You compare them, you see that they are the same element, which means they have the same number of protons, but they have different masses. Okay, these are isotopes, so isotopes are kind of like sibling atoms. Okay, so it's the same element, they come from the same family, so to speak, but they have different masses. Okay, so they're slightly different. Examples of isotopes from our table, well, if we go back, we see that we didn't have any of the same elements, so we didn't have any isotopes. So no isotopes. Okay. All right, now let's look at average atomic mass. All right, average atomic mass is going to be percent abundances in decimal form times the isotope mass, and you add those up, and that's your average atomic mass. So here we have 778.92 times 0.5069. If you take it out of percent and put it in decimal, and that gives us 40.004548. All right, and then 80.92 times 0.4931 is going to be 79. Oop, my bad. 39. I don't know where I got 79. 39.901652. Then you add these numbers up, and that gives us 79.9062 grams. All right, calculate the weighted atomic mass of iron if 15%, so 0.15, is 55, so 0.15 times 55 gives us, all right, put that in the calculator. All right, and then we got 0.85 times 56, put that in the calculator. All right, let's add them up, enter, and we get 55.85 grams. Okay, so that was the total. So percentage in decimal times mass, percentage in decimal times mass, and you get your average when you add them up. Which isotope of copper is more abundant, copper 63 or copper 65, if the average atomic mass of copper is 63.546? Well, when you round that, that rounds up to 64. Okay, so what that indicates is that, well, copper 64 is not a choice, so that doesn't help me at all. So now let's look at the actual masses we can deal with, 63 and 65. 63.546 is closest to 63, okay? So that means that it is going to be most likely that copper 63 is the most abundant isotope. All right, so whatever the mass is closest to. All right, here's a little extra credit isotope problem. All right, wants us to calculate the percent abundances of boron's isotope if we know that the average atomic mass of boron is 10.8 and the masses of the two isotopes of boron are 10 and 11. So the average atomic mass is equal to the mass of the first isotope times the percent abundance plus the mass of the second isotope times the percent abundance. Now we know that x plus y always adds up to 1, right? So if you had like 90% and 10%, it'd always be 100%, and 100% in decimal is 1. Okay? Now, instead of putting this in two different variables, we really need to be looking at this in terms of just one variable. So let's try to get the y out. So we're going to solve for y. So minus x. Okay, so that cancels that. So y equals 1 minus x. So we're going to use that in this equation to try to determine the percentages. Okay, so now we're going to distribute the 11 into the 1 and the negative x. We get 11 and negative 11x plus 10x. So that's really negative x plus 11, and that's all still equal to 10.8. Minus 11 gives us negative 0.2 is equal to negative x. So x is 0.2 or 20%. So we have 20% of the isotope associated with x, which was boron 10. That means to get to 1 in decimal, so that would be 0.8, or 100% in percentage form, that would be 80%. So 80% has got to be the other isotope, which is boron 11. Okay, so that's how you would tackle that problem.